Hello, everyone. Welcome to Methods 2, Week 3. As I stated in class, I will now start recording the software tutorials that I go over during our lecture days. Before I get into the tutorial that I went over in class, first I'd like to review the assignment again for maybe some people that weren't in class. So this assignment is a direct progression of what we've already done, where we redrew the plans and sections and elevations from assignment 1. Now we're going to move into 3D modeling and actually construct these houses three-dimensionally. So as we get into that, you should probably go in this order of modeling the components. I found these to be the simplest way to actually start 3D modeling, as well as it gives you a nice foundation to use. So first off, starting with the foundation, and then modeling the primary structure that is supported on top of that foundation. After that, you can model the secondary structure and then the exterior finishes. Once we have all those components done, then we can start modeling things such as windows, interior finishes, any major millwork, what can we think of, woodwork or cabinetry. And then furniture is the very last thing. For this, we will not necessarily need to be modeling furniture, but you can if you wanted. And if you haven't already, I would go back and look at the lecture that was given in class. We're not just going to be modeling boxes in Rhino. We're actually going to be modeling the entire components that we see in the wall assemblies. So what I mean by that, like the structure, the studs, the interior finishes, as well as the exterior finishes. We won't be modeling things such as installation. We can, at this point, just leave that as an open space, like an airspace. So what's due for February 4th, next Tuesday? The assignment will be uploaded to Canvas and Miro, similar to what we did on this last assignment. As well, you need to be modeling only at that point the foundation and the building structure. Of course, you can model more, and this isn't a dedicated grade, but it's a nice checkpoint to see how you're doing so far. So exporting those 3D images of your model, showing those different views, you can use the command view capture to file to export those images. Just be sure that you turn off any layer that might have those linked images or line work. So we don't want that to interfere with the actual 3D volumes that we're going to be creating. Then for the 11th, the following Tuesday, you will export 4 images of your complete model. That is everything down to the details of the shingles or the wood finish on the exterior. Again, the rubric, 75% of your grade will evaluate you on the level of completion of modeling the building. What that means is how complete is your building? Like, is it done? Have you done all 3 floors? Have you modeled every element, every stair? And then 25% of the grade will evaluate you on the precision of the model. This is not about accuracy of the building component thicknesses or door sizes or etc. This is grading in reference to making sure that a flat wall is flat in Rhino, and that where 2 walls touch, there are no gaps in your model. So we need to make sure that everything is lined up accordingly and that these very straight elements are actually straight. Okay, as reference again, the Rhino commands that I'll be using are introducing in this tutorial or on this week's module as well. Everything that's been bolded are new commands for the most part, and it's 2 pages long, just so you see. Again, all this stuff is found in the modules in Canvas, where it's next to the assignment 2 lecture and the round commands for this week. Okay, let's get into modeling. So at this point, you should have all of your drawings done. I'm just going to work with these 4 that I have created, the floor plans and 1 section. Of course, if you have more, use those as well. So we're going to start off first. I'm just going to turn off my picture layer. Well, actually, before we get into that, what we're going to do is line up all of these drawings on top of each other. So I'm going to group the like elements together. So my first floor plan, I'm going to group that one. My second floor plan, I'm going to group that one. And same for the third, and then for my section as well. So in these groups are the line work in addition to the pictures, the reference pictures. And if everything is going according to plan, all of these elements that are consistent throughout, like the location of these columns, the size of the columns, the size of these walls, should be consistent throughout your drawings. If not, now's a great time to update those. So what I'm going to do now is just move these plans on top of each other. And I'm going to move them using the move command and just make sure that I move for instance, the second floor plan to a common point that it has on the first floor plan, which is just the edge of this, the corner of this fireplace in the case of the Delta shelter. Then I'm going to do the same thing for the third floor plan. And now all of these plans are on top of each other. And now I'm going to go back to my section. The Delta shelter has this nice little key plan actually showing you where this section was cut, right? It was cut along this edge here. It's looking this way to the right. We can tell that just by these little annotation lines. So what we could do is orient this to where it lines up with our plans. So first, foremost, as you've probably learned in class, this is our gumball widget, module, whatever you want to call it. In order to turn it on, you need to come down to the very bottom next to Smart Track. And you can click this gumball to be highlighted. That means it's turned on. Now every time I select an element, this little gumball icon will pop up. And in gumball, it kind of has a shortcut to many different things. The arrows, that's the shortcut for move. You can drag them and it will move the element however much you drag it, or you can just touch it, like click it, and you can specify the distance that you want them to be moved, such as like 10 feet, right? It moved it 10 feet over. That's the same for every arrow. Now, the squares on the outside perimeters, those are shortcuts for scaling. If you click one of them, again, you can type in the distance that you want that to be scaled, or you can drag it. And I can see that it's only dragging it in one direction, which is our scale 1D. If I want to scale things in 2 directions or uniformly against all sides, I can hold down Shift and drag this again, or tap it, right? And it will scale it uniformly against all sides. Now the last widget on here, or last shortcut, would be this little arc. And this is your rotation shortcut. So I can again drag that, and based on where the arrows are is telling me which way it's rotating. And since I have my ortho turned on, it's only restricting me in those 90 degrees. But if I were to click it, I can specify exactly the degree that I want this to be rotated for any reason that I may need that. Now that I have that situated, I'm going to use this gumball rotation and actually rotate it to where it's in line with where it should be. And so I'm going to do -90 because I want to go against the arrow direction. And now I'm going to move. So I know that this foundation is actually this foundation here, more or less. And I can just drag it out of the way for now. It's fine. And so now this section is lined up with my plan in relation. Now what I can do is explore another viewport rather than just the top view. I think up to this point, everyone's been working in your top view, which is great. It's what we've been doing for 2D drawings. This restricts you in a 2D view. But now that we want to start exploring three-dimensionality, we can double click our top view or click this little button here that says 4 viewports, and we'll open all 4 viewports. Now we see our three-dimensional workspace. And I can see that some of these plans are not exactly on top of each other. So I'm going to do set PT. I'm going to select everything besides the Z. I'm going to select only the Z. I'm going to click the point next to the other floor plans and actually move everything to that Z point. Now, what I need to do is actually locate these floor plans at their exact heights. And what I'm going to use for that is my section. But first off, my section is still flat, horizontal, and I actually need to upright it. So again, I'm going to use my gumball, and this time it's the green arc, right? Because that's the one parallel to this face in that direction, or perpendicular to that face, but going in the correct direction. I'm going to click that. And again, I see that it's wanting to rotate the opposite way. So I'm going to do -90 again, and now it's standing up straight. I'm going to go ahead and move this again to be in line with my plans. So I selected the edge of that wall, and I'm going to just snap it to one of these adjacent walls, right? So now that I'm looking at this section is cutting through my plans. And I can, based on where the section is taken, it's to the very left, right? I can just use my gumball and kind of guesstimate exactly where that is based on what I see in the section. Right, I see the beginning of these stairs, so I know it's before the stairs. And I see this little door opening here, which is right there. Okay, so my section is in a good place. And I'm just gonna turn off the layer that has these images now that I no longer need them. I was mainly using it just to understand where the section was taking place in the plan. And for some people, maybe you don't have that key plan and you just kind of have to estimate or make your best judgment about where that section is taking place. Okay, so So I'm going to turn off that layer. Now I can see I have my one section standing upright, and then my three floor plans are all on top of each other at the same Z level. Just not great. And they're not even correctly placed in relation to my my section. So again, I'm going to use my set PT command and make sure I only have my Z active, and click OK. And I have selected the first floor plan. I'm going to just touch or snap to with my O snaps on and near. I'm going to snap to the top of my floor, my first floor. Okay. I'm going to do the same thing for the floors above. So this is my second floor plan, set PT. I'm going to snap to my second floor. Then the same for my third floor. Right? Now I have all, if we were like thinking of this like as an X-ray, right? We are seeing through the house now, just based on what our drawings look like. Which is pretty nice. Now what I can do is start to use commands that will actually make some of this line work three-dimensional. And for this stage right now, we only need to worry about the foundational elements and the structural elements. Now, the structural elements I can see are these I-beams that run in both directions, as well as the foundational elements are these round concrete piers. Additional to the structural elements is we could also model the roof and maybe some parts of the exterior wall. Now for reference, I'm just going to drag an image of the house into Rhino. It's going to prompt me the same thing as we did with the plans and sections. What I want this image to be, I'm going to say picture, and I'm just going to drag that over here. I'm going to throw that in a new layer and say reference photo. I'm going to change that objects layer. Now when I'm looking at this reference photo, I can see what the structural elements are. Again, like it's the metal beams and columns, and the foundational elements are the concrete piers. So now it should be pretty simple enough to model the structural elements, right? You can see them here, 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 kind of everywhere. Okay, so let's go back to my perspective. And what I'm going to just first do is select these concrete piers. For now, I can go ahead and ungroup these again. They did their job. I no longer need them grouped. What I am going to do, though, is create new layers for each element that I create. So first I'm going to name these piers. I can make a layer called columns, beams, and roof. I think those are the 4 elements I'm going to create right now. So I have my piers layer selected. I'm going to select all of these curves, these circles that I know are the piers. I'm going to extrude those. And the command I'm using is extrude curve. When I have extrude curve, I can see that it's extruding them in the Z direction, which is good. And I can dictate or decide how tall I want these to be. I'm just going to select the bottom of this point here because that's in my section. That's how they originate, is from that point. But when I look at this, they're actually too tall. If I go to my side view, for instance, right, they're much taller than they actually need to be. So what I can do now is scale 1D, right? Make sure I go to my top view or whatever, side view, perspective. This is when you should be working all 4 views. And I want to select the very top of that column. I can now go to my right view again, and I can select the top of that line, because that's how tall it should be. Now, when looking at it though, and looking at the object types, I have 4 open extrusions. I can close these extrusions by using the command cap. And now those extrusions are closed and they're like theoretically solid. Another thing I can do is I'm going to select, just moving forward, select the column layer. I'm going to select these columns. And I'm going to, again, extrude those. When I'm extruding this curve, I can click this option that says solid, make sure it says yes. If it says yes, then I don't have to use that command cap, because when I determine the size of these, it's already going to be in a closed extrusion, as I can see here. So now we have our columns. What I'm going to do though is select these columns by going to my layer and doing select objects in that layer. It's going to select all my columns. I'm going to scale them to make them taller. How tall do they need to be? Probably to the height of my roof, right? Maybe not all of them, but definitely some of them. For instance, if I look at my reference photo again, I know that these columns out here actually don't go up to the roof. So I can actually scale those back down. To the height of that second floor. And if I need to make them smaller in the future, I can as well. There's our 4 main house columns and the 2 columns that are supporting the walkway. Now what do I need to do? I can work on these horizontal columns that connect, these horizontal beams that connect the columns, which is probably a nice move. I'm going to ungroup that section. I'm going to select all those beams. Goodness. Move my layer. I'm going to extrude again. And I'm going to extrude them to the face of this column. I'm going to select all those beams, use my layers, select objects, and scale them again. To the face of that column. Now we have our columns and our beams. Doesn't look like our columns and beams are actually lined up with each other. And I can look on the pictures and actually verify if that's correct or not. which it may be. If I go back to the images of the house, I can see that the beams are actually proud on the exterior, and if I zoom into here, they're actually outboard of the columns, at least on this corner. So it looks like it's okay right now. It just means that instead of extruding them to the face, I actually need to extrude them to be proud. So I'm just going to go to my midpoint and go to this edge and go to the edge of the column like that. There we go. We can do the same for the other side, but I'll let you do that. Next up, I'm sure we have beams running this opposite direction. What I'm just going to do quickly is rotate these. Using my gumball, I can press Alt, and if I click this blue arc, it's actually going to copy that selection that I made. Again, I need to clean these up to make sure they actually match and align. And so let's move on to some other commands that we can use to do that. First off though, before I get into that, let's go over more of the three-dimensional commands. So we saw the simple command as extrude curve, right? And that extrudes a simple curve. Another command that we can use is planar surface. And now this creates a surface from that curve. This surface has no z dimension, right? It's flat, it has no thickness, but it is considered basically a solid, right? Where curves are just lines. This is a plane. What I can do is extrude surface, SRF, and now I can extrude, same thing as extruding from a curve, but now I'm extruding from a surface. I could also offset surface. If we think about offsetting curves, this is the same thing, except now it's a plane. And I can specify a distance that I want that to be offset. And I can specify if I want that to be a solid or not. If it's not, then it will just create another surface at the distance that you specify. If it's solid, then it will create a box. So I'm going to just say 5. And I can see this little preview here. That's telling me what direction it's going to offset. If I want to change the direction of that, I just need to click it. And now the arrows are facing the opposite direction. Then click Enter or right click, and now it's offset that surface. One other nice command is, and this may happen for a couple students or a couple houses, is if you have two curves similar to what I have drawn here. We can even see that happen in the roof of the Delta shelter, which we can tackle that in many different ways. Is it's at an angle. We can't just extrude it straight up and down. But we know the location of one of the bounding surfaces or bounding curves and then the other one. What we can do is loft and select the curves that we want to loft. And now it's giving us this preview. Only thing that we need to worry about for this preview is that both points are generally in the same origin in relation to each other, right? The bottom left corner of this is kind of the same bottom left corner of this. We need to make sure that the arrows are pointing each other, or pointing in the same direction. So they are. I'm just going to click OK. And now it's going to give me this little dialog box. It's going to ask me, what do I want this to look like? I'm just going to say normal, which is fine. And I can click OK. It has given me an open poly surface. I can get and cap that easily. And now it's a closed poly surface. It's like a closed rhomboid. What else I can do is if I have these three objects and I want to work backwards now, like go back to my curves to maybe alter something or rework my drawings, right? I can duplicate the edges or the borders or the face border. So what I'm going to do is dupe edge. I'm just going to select these edges here. I'm going to click OK. And now I have recreated these lines just based on the 3D object. Similar, I can duplicate face border, right? I had these two before, but I didn't have this line, this face. So if I want to have that face, I can dupe face border. I can select that face, and now I have that border, right? One other thing we can work on is pipe, which is going to be very useful for things such as handrails, right? I'm going to type in pipe, and it's going to ask me to select a rail. This is crucial why we need to still work with these curves and why such things as dupe edge or dupe face border come in handy. A rail is a curve. So if I select this curve, now I can see that it's prompting me with creating a circle, which is like the extruded cylinder that you find on rails, chair rails or stair rails or whatever they may be. It's going to ask me for the radius for that closed pipe. I'm just going to type 3 inches. Well, probably smaller. Let's do 1.5 inches. Yeah, so to give me a 3-inch diameter. And if we want to make it have another size of radius, like we can think of the pipe growing in or shrinking in diameter as it gets further along. But for this, we don't need that. It's a continuous size throughout. So I'm just going to click OK. And I can see that it's automatically created a very nice extruded cylinder along that curve. And it's even mitered the edges for me, so I don't even have to do that. Next thing I can do when I'm looking at this box, and maybe when we get into Windows, this will be more crucial as well, is the booleans. Actually, let's move back to our building. I'm going to just turn off everything besides my columns and beams. I'm just going to do that by selecting all these layers and clicking the light bulb, and it automatically turns them all off for me. Okay, so I have these beams, right? And I know based on the reference photo, which I just turned off, that they come to this kind of corner condition where they meet and they match up really nicely. But first I need to, of course, make them meet. So what I could do is extrude surface. Instead of scale 1D, scaling in one direction, now that I have the surface, I can just extrude it, which is nice. And I can extrude it to that point, and then I can do the same thing for this one. Know that they meet in the middle. There we go. We have these corners that are touching each other. They're fully intersecting each other, which is not great if they're considered solids, right? That's physically impossible. So what we can do to fix that is we kind of have to do a couple steps to actually get this to line up really nice. First, I'm just going to draw a line from the inside corner to this outside corner, right? And I'm going to scale it from the midpoint to the exterior and just make sure it goes past this line. If we're working in Rhino, if you get the tolerances too close, then it sometimes misunderstands what you're trying to do. So if we just make sure it goes past a little bit, we're good. And similar to what we did when we were drawing the plans, when we had a line that crossed over where it wasn't supposed to or whatever, we can trim and split. So that's what we're going to be using for these 3D objects as well. Except if we use trim or split on 3D objects, then it will just cut them away and it will no longer make them closed polysurfaces. They will no longer read as solid. But what we could rather do is first I'm going to extrude this curve. And now I have like a construction face for me. This isn't going to stay in the end result, but that's there for now. What I can use is the Boolean terms. First, I'm going to use Boolean. Well, let's see what they do first. Boolean union. I'm going to ask me to select the surfaces or polysurfaces to union. I'm going to select both of these beams. I'm going to click enter. And now when I select them, it's no longer two elements, right? I can look at my object. It's not telling me that it's 2 units. Even up here at the selection, it's just telling me I have one closed polysurface. Those are now considered one element. They've combined. I just undid, and now let's go through some of the other Booleans. Boolean difference. Select surfaces or polysurfaces to subtract from. So I'm going to select the left one, and then I'm going to subtract with the right one. And let's see what happens. So with what happened, I can see that the left one now looks like it has a bite taken out of it, which is almost on the right track, right? And I can also see that it has left over this little piece here. It's only deleted what intersected with this beam. Okay, so let's undo that because that's not exactly what we want. Boolean intersection. Let's see what that one does. So select the first set of surfaces or polysurfaces. I'm just going to select, again, the left one. Then it says select the second set. I'm going to select the right one. If I press enter, now it's only leaving me with where those two objects actually intersected each other. It's deleting everything else and only leaving this little corner, right? That's not exactly what we want either. And again, with all of these commands, if you leave the delete input no, it will leave the original input, but it will still give you that final result. So if I do the same thing, I'm going to delete input no this time. It's like the left one and then the right one. See, the originals are still there, but now I have this third element that I've created. Let's delete that. I don't need that. Okay, last one. Boolean split. Well, not the last one, but let's go to it. I'm going to select the surfaces that I want to split, which are these two. And now what am I using to cut? It's this surface that I created here, right? That's kind of like what I'm using as my scissors. So I'm going to select that. And now nothing's really happened, right? But if I delete this surface, I can now see that this has been cut away at this corner. So if I delete the elements that are remaining from the originals, right, it has nicely created that continuous expression of those joined beams, which is nice. The other Boolean is Boolean to objects, which is basically all of those Boolean elements or Boolean commands wrapped into one. Let me show you what that looks like real quick. So Boolean to objects. Select the two objects to Boolean, right? And now it's going to ask me to iterate through the Boolean results, in which that means is if I just click, this was Boolean intersection. This is Boolean difference. Same thing, but on the opposite side. This is the inverse of Boolean intersection, right? This is everything that is left over. And this is Boolean union. And I can just keep going through all of those. The only thing it doesn't really do is Boolean split. So I'm going to redo my Boolean split. Delete these elements. And now I have these two beams. Then, if I wanted, I could Boolean union them together. For this, I wouldn't recommend that. I would still like to see these as individual elements because they are actual individual elements that are put together. But we could do that. I'm just going to undo that for now. One thing that is kind of like a graphical thing, maybe frustrating to everyone, I know it is for me, is seeing these display lines that intersect are nice clean shapes. And it's just due to when you Boolean union things together or extrude surfaces from an existing surface, it kind of reads it as a new instance or a new part that has been added to the original. But in order to kind of go back and treat this whole thing as an original element, I can use the command merge all coplanar faces. And we can see based on the left one and the right one, now this all like faces that are on the same plane have been merged together, unlike this one. One thing opposed to that, though, is if you needed to retain this information about where things came together, I wouldn't merge all those faces. For instance, if you wanted to extract a certain face and only one of these faces, right? You don't want to extract this entire top face. So let's use that command, extract surface. It's going to say select surfaces to extract. I'm just going to select these two. Now it has basically removed these surfaces from our poly surface. When I select my poly surface, now I can see that they are an open poly surface. They are no longer closed, right? They're no longer solid. But if you were needing to edit something in here, for instance, I'm not sure what, like maybe I wanted to create a new surface with using this surface PT and just like create like a new surface like this, right? Like for any reason. Now that can do that easily. Don't know why you need to, but you could. I'm just gonna undo, and I'm gonna merge coplanar. Now it's clean. Now it's nice. The last command that I'll go over before I move into display modes is going to be explode, which similar to extract surface. Well, when extract surface targets one surface to take away from the whole. Explode explodes everything. So if I, and you can do this for lines as well, explode that, and now when I select this, it's no longer a poly surface. It's no longer a surface. It's no longer an object made of multiple surfaces, but it's actually many separate surfaces. Okay. Undo those. You may need to use that, maybe not. Oh, one last command that I think should be useful is rotate 3D. I think I went over this in class. So we know we have this roof, right? We have the curves that we could just extrude. It's already at the correct angle. But let's say we didn't have that, and we just had this box, right? And it's not at the right angle. What we could do is type the command rotate 3D. It's going to ask me where do I want my rotation axis to be. And because I want to rotate it, if I'm thinking about the gumball, right? This is the line that I want to start the axis. And the first reference point will be the bottom. And now it's rotating along that axis that I selected. Right? And I just can make that go here. And now I have rotated my roof to the correct angle. Without using the curve. And that's basically it for right now. We'll have a workshop on Thursday's class to go over any questions or concerns that you've encountered with either like the plans or maybe like your drawings aren't completely lining up correctly. That's okay. This is not meant to be 100% accurate depiction of your houses. We're really just trying to get to the true essence and the closest that we can, given the information that we have, right? If your chimneys aren't lining up, I mean, that's probably not the architect's fault. Like, they're probably have drawn those to where they are lining up. It's probably just our misinterpretation or an error with us tracing the existing plans. Same thing for wall thicknesses, right? We have interior wall thicknesses. They're probably all constructed the same way. They're probably all the same size. So they should be reflecting that throughout the floors. Same thing as these columns, right? These columns are probably all the same size. And we know they go straight through the building. So they're continuous throughout and in the same location throughout. So those are something that we can tackle. I'm just going to Boolean difference this with my roof. I can delete these components. And so this is almost more or less what we're expecting to be due by Tuesday. Of course, like finishing up kind of what I did here, as well as creating the railing. If I go back to the picture, going back to create this structural railing here and the rest of the floor beams and all that, but that's more or less it. Okay, let's move to display options or display modes. And maybe some people have already ventured onto this. My top view is automatically in, if I right click on the top name, it's automatically more than likely in a wireframe display mode, which is just kind of like X-ray. It's only showing you the lines. If If I were to go to shaded, now I can't see any of the lines that are beyond this extrusion, right? It's hiding those lines because it's a solid object. Same thing from my perspective, right? My perspective is probably more than likely already in shaded, so I can see the solid objects. But if I were to turn that to wireframe, now I can see through these elements. I'll go through all these rendered. It gives you kind of realistic shadows. Ghosted, similar to shaded, except now I can see through some of these elements, which is nice, right? I can see these beams through the roof. X-ray, you can see kind of like a mixture between the wireframe and shaded. And then I'm going to drop down all the way to Arctic, which is nice. It's like a white model. It has flat shading, so you can see some depth and dimension, but there's not necessarily like a sun, right? There's shadows from all directions. Shaded, for the most part, is going to be the best one to work in for perspective, so you actually can understand what's solid and what's void, as well as it's going to be the fastest way to get you the best information and not kill your computer. Believe that's everything that we kind of went over to this point. And these are commands that we can be using throughout. Again, don't forget about the previous commands that we've used when we were creating our floor plans and sections, such as like the array, the joining, all those things. Scaling, scale 1D, those will all be very useful moving forward, right? For like very repetitive elements. Like we can create a 3D element, an extrusion, or whatever it may be, and we can array it. I'm just going to do array linear because the first one that popped up, right? And I can create a series of boxes that are all the same. Same thing for array normally. Now that we have our 3 directions that we're working in, theoretically we could make an array in 3 directions. I'm just typing 30 for all of them. Now we have this matrix, this grid of all these boxes. Don't know why you necessarily need that right now, but it's there. Same thing for like the wood studs, right? Inside the walls, we draw one wood stud and we can array it at the typical spacing, 18 inches on center. And there we go, there's our wood studs. Okay, everyone, hope this was helpful, and I'll see y'all in class on Thursday.